The original problem statement our group came up with in the previous phase was that the over-reliance of fossil fuels has contributed to the degradation of air and water quality. This statement was based on research collected on the effects of fossil fuels on the planet and from surveys where we asked people what they believed was the biggest cause of bad air and water quality. And fossil fuels was the number one outcome of that survey. The revised problem statement we came up with is how do we encourage people to reduce their reliance on fossil fuels energy? The method that was used for the revised problem statement was the Dunker diagram. The Dunker diagram basically focused on the present state, where then you list the desired state, and then possible pathways to that state, and then possible solutions to those pathways. And it's all like branches. Our desired state is having increased air and water quality. The pathways focus on renewable energy sources, enhancing systems that pollute already, and general methods to combat pollutants. The solutions you can see varied from building windmills, developing cleaner systems, recycling and reusing, etc.
With our revised problem statement, we went on to brainstorming. During our brainstorming sessions, we tried using direct and fantasy analogies to help brainstorm general solutions without much focus on what's possible or within our constraints. This is a picture of our first group of brainstorming ideas we generated. We gathered ideas that were similar into categories that helped us further develop some of these points into potential solutions. Once we had a few good potential solutions, we used our criteria and constraints to weed out the solution paths that were impossible or extremely unrealistic, which is how we went from a bunch of general solutions to solutions that are more possible and meet our constraints.
From our brainstorming, we were able to take out the best solutions and categorize them as shown on the previous slide. Of the many solutions we came up with, some of the best and achievable ones are an app that allows you to interact with others to carpool together, getting more cars off the road, an overhaul delivery system that takes delivery trucks off the road and uses electric drones, a barbecue that runs on strictly solar power, and a bus rewards app that gives you incentive for people to use public transport. We then decided that to get a true score of our solutions and how they compare against our goals and constraints, we needed to first use a pairwise comparison to evaluate the weights of the metric. This allowed us to see which metrics should be more important when evaluating which solutions are best. The metric used are: the product is affordable, does it support the change to clean energy, does it increase air quality, does it increase water quality, and finally, does it reduce the use of fossil fuels? For example, as shown in the image, the affordability was the least of our concern when compared with the increase in air and water quality. After totaling up the values of our metrics, we then use those values as multipliers for our next comparison chart. This chart takes our solutions and compares them to our metrics. 3 of our members rated each solution how it compares to the metric on a scale of 1 to 10. Then when averaging each solution's metric value, we multiplied that by specific metrics multiplier. This way, the metrics that didn't matter as much were weighted less compared to the ones that were directly involved with our goal and problem statement.
Our top 3 designs are the delivery drone, the solar-powered barbecue, and the electric bus. To further examine each design, we've added additional constraints to address any outstanding factors. We've set the price of this drone to be around the average market price, approximately $2,500. This drone will rely on solar energy and it would carry packages to each household. The delivery drone serves to reduce the use of delivery trucks, which reduces traffic and CO2 emissions. As well, the demand for delivery drones is skyrocketing, according to this graph. We've approximated the market price for the solar-powered barbecue to be around $1,200. Rather than using charcoal or gas, it utilizes the sun to cook food. As well, there is some demand for this kind of product during grilling season. According to sources, the average market price for electric buses is around $750,000. This bus would produce zero emissions and reduce the amount of traffic, and according to the statistics, there is reasonable demand for public transit pre-COVID. Applying the secondary constraints we've added, we've decided on the delivery drone as our final design. It doesn't exceed the average retail price of comparable products, it's powered via renewable energy, it reduces CO2 emissions, it has a high ceiling for innovation, and there's proof of interest in the market. We believe that the other designs do not have a high enough ceiling for innovation, nor market demand. Thus, the delivery drone satisfies all our criteria and is therefore our most valid candidate.
With our design, a successful project should fulfill the criteria and the requirements. It should successfully impact the target users and also should have a concrete project milestone. In order to impact the target users, the proposed design should fulfill the user's need and also it should be affordable and easily accessible for users.
That is it for our presentation. Thank you all for listening.